Welcome, polar bears and polar cubs. Today we start predicting products. I'm going to just kind of lay it out. First, this is some very difficult stuff that we're about to do. These concepts you guys are able to comprehend. You just need to take your time and make sure that you are reviewing things. When you have questions, making sure that you're asking them, saying, hey, Mr. Madej, will you go through an example with me, is the best way for us to kind of go over this. So first and foremost, we're going to talk about synthesis. Well, synthesis is when you have two or more substances that combine to make one. They only make one product. So we have a nice general formula, and it is AX goes to, or A plus X goes to AX. Well, A is either going to be an element, it's going to be an element. X is also going to be an element. And we're going to make a compound. And this is synthesis. So let's run through some examples of synthesis. Well, our first example is aluminum plus iodine. Well, on the product side, what you need to do is you need to remember your rules when making formulas. So on this side, you will cross charges. So aluminum has a +3 charge, I has a -1 charge. You're going to predict the product first and then worry about balancing last. So once you have this as our charges of our reactants, you're going to put them together. So you'll get AlI3. At this moment, we're going to worry about balancing. So I noticed that the I's are off. So in order to balance the I's, I need a 2 here and a 3 here. And then that makes I have 2 aluminums. So I put a 2 here. I'm going to have you guys try the next one, and then we'll go over it. 3, 2, and 1. All right, so on this next one, Na has a +1 charge. Cl has a -1 charge, giving us NaCl. If you balance that now, you have 2 Cl's on the left, you need to have 2 on the right, and that makes 2 Nas. Go ahead and try the very last one. So 3, 2, and 1. This is going to make hydrobromic acid, HBr. You have 2 H's, 2 Brs, so you need a 2 there. We're balanced. We're good to go. These are called binary synthesis, meaning that there are only 2 elements in them. There are, however, 2 special cases when it comes to synthesis. The first case, again, it's A plus X goes to AX. Now, this is nonmetallic synthesis. So it's a nonmetallic oxide plus water goes to an acid. Now, it goes to an acid, and we're trying to find the simplest way to write that acid. So, for example, on the first one, we're just going to put them all together. So how many H's do I have? I have 2. I have 1 C, and then I have 3 O's. If you can name that acid, you're done. So this acid, again, would be carbonic acid. I can name it. You can name it. I know you can. The next one, if you try this example, combine them all, you have 2, 2, and 6. Now, what I always tell kids is to look on the back of the periodic table. When you look on the back of the periodic table, nitrate is NO3 minus. Well, that means that for every N and 3 O's, I need 1 H. So really what you could do is pull a 2 out, and you get 2 H NO3. Okay. These are some of the more difficult of the synthesis because you guys just need some practice on knowing what kind of acid it's going to make. The last special case, again, it is A plus X goes to AX. Now, on this one, we're making bases. Now, a base is signified by the OH minus. It is metallic synthesis. So you have a metal oxide plus water. What I like to do is, even if I have water written as H2O, I change it to HOH. Okay. And the reason that I do that is so you can see that there already is one OH, and then we get a second OH right here. So really we have two NAs and two OHs. So how we balance it is we put a 2 here. Again, the metallic synthesis always make a hydroxide. The non-metallic synthesis always makes an acid. If you have any questions, please let me know. This is the time to ask them and ask your teacher to run through examples.